Okay, so as Carrie mentioned, my name is George SPANOS. For those that don't know me, I was at the Naval Research Laboratory for 21 years, and then 3 years ago I became the Technical Director at TMS. While I was at the lab, I did a lot of work in the area of ICME and three-dimensional materials analyses. So I have some experience of boots on the ground in this area as well. Today, though, I'm going to talk about a study that was just completed by TMS and our volunteers, Integrated Computational Materials Engineering, a study on implementing ICME in the Aerospace, Automotive, and Maritime industries. As Carrie said, you all got a copy of that study in your registration packet, so it looks like this. I'd like to acknowledge funding support for that from DoD, the Office of Naval Research, and the Air Force Research Lab, the Department of Energy, and the National Science Foundation. Another thing on behalf of TMS I'd like to recognize for this Congress is funding support from two government agencies, NIST and the Office of Naval Research. It was not in your book because due to the sequester, that support is coming very, very late, but we're still very thankful. So back to the report. My boss, Jim Robinson, always tells me that in any given talk or any given meeting, there are usually people can't handle more than about 3 key takeaways. So the 3 key takeaways that I'd like you to walk away with today are centered around implementation, in the near term, and integration, what I'm calling the 3 I's. So just to elaborate a bit, the charter given to our teams, our ICME implementation teams in this study, was to provide detailed guidance for implementing ICME. We didn't want another study that describes some of the long-term issues that had to be dealt with. We were going after how do we implement it now in product development cycles. Another part of the study was we focused on near term. We all debated back and forth what we meant by near term, and in the end we defined that as beginning or initiating what we called an ICME Accelerated Product Development Program within 3 years. And we discussed that time frame a lot, and all the experts agreed that they thought it was feasible to begin implementing these programs within the next 3 years. And then integration, of course, is the other I that I'd like you to take away. Integration of a number of things, science and engineering disciplines, materials manufacturing and design, and various personnel types, and in particular the integration of models and experiments are critical as well. So what was the motivation for this study? ICME, I think we can all agree now, is recognized as a discipline, and awareness is growing worldwide. The 2008 National Academy studies really put ICME on the map. They named it that discipline and provided overall vision and discussed a number of broad cultural and technical issues. There were a number of prior studies to that, academy studies and others, that discussed materials by design and so on, were the precursors to this study, and they were equally important. Since this time of the 2008 Academy studies, a number of things have happened. This is the Second World Congress. We had the first one 2 years ago, a number of journal issues, new books, courses, workshops, etc. So a lot is happening in this area. Although there have been some successful ICME case studies to date, to realize this vision more extensively and more rapidly, we felt a focused study was needed to define the frameworks and pathways to implementing ICME in the near term in these 3 industries. Another important goal here was to support the MGI goals of accelerating development at reduced cost, which Jim discussed, of advanced materials and manufacturing processes, and the MGI talks about doing this from the point of materials discovery to deployment. Okay, I wanted to give a little background now on the study. I'll talk about some highlights of the study mostly, and I wanted to give you a feel for how the study occurred, because it's important to look at the output in that context. It was a 13-month study. We started it in June of 2012 and ended in the beginning of July with a final printed hard copy of the report from that study. I already mentioned it was supported by these agencies. The study was centered about lightweighting and to some extent propulsion as well in the 3 industrial sectors, aerospace, automotive, and maritime. There were 5 ICME implementation teams of experts. 3 teams were centered about, 1 team about each of the 3 industries I mentioned. The 4th team covered pervasive cross-cutting issues across the industries. And then we had a 5th review team which took the initial drafts of the report and really hacked through it. So the final report can be thought of as effectively a field manual for how to implement ICME in these industries and also in other industries. I like to think of it as if I were in industry and wanted to start an ICME program, I wouldn't want to reinvent the wheel. I want to see what the experts developed as the framework first. The whole study was reverse engineered for this public rollout here at this second ICME World Congress. Again, you have the hard copies that you received at registration. I'd also mention that as of this afternoon, we went live with the free PDF download version on our website. So anyone can download the study. And it has, the PDF version actually has nice hyperlinks that take you from sections of the executive summary, for instance, to specific areas. So you might want to download that even if you have the hard copy. So what were the overall goals up front? To provide detailed guidance for implementation of ICME, again, for various stakeholders to be able to implement ICME, and I'll talk about those stakeholders in a little bit. To develop these frameworks, these integrated frameworks, which I'll show an example of one. It includes the steps, the computational tools, experiments, personnel, flow of data and information, and decision points across the product manufacturing development cycle for a new materials product. The implementation time frame, the charge given to the teams was 3 years to begin an ICME accelerated product development program. And they felt that was very doable, particularly the industrial people felt that we should be starting many programs in this next 3 years. We're there. The study also, I thought, could nucleate the self-assembly of ICME teams in our programs through both the interactions of the people on the teams, but also as people read the report, the development of ideas and such that would allow people to talk to other people and then sort of self-assemble into potential teams. Okay, the project team was TMS led the project. Was responsible for the final report and the dissemination and promotion. I'm the principal investigator. Project coordinator was David Howe. David really did yeoman's work on this project. He probably handled over 1,000 emails between 50 expert team members back and forth with homework assignments and so on, and many meetings. Essentially the whole staff at TMS was involved for our in-person meetings and our grants, acquisition and spending of the grants and so on. The final report, our editorial team. So it was really a team effort at TMS. I'd like to acknowledge the Next Site group, which was our professional facilitator that we brought in. They facilitated all the in-person meetings and they worked extensively with us to convert the team inputs to the final product. But of course, the real bones behind this study was the ICME implementation teams. Those are our subject matter experts. There are volunteers that are responsible for all the content in the study, and they were really the brains and experience behind it. So I know a number of the ICME implementation team members are here. I'd ask that they all stand up a minute so you can just recognize them and feel free to talk to them about the study throughout. So could you all stand up if you were on the ICME implementation teams? There are not too many. Okay, not too many. I'm going to ask you very quickly just to tell your name and your company.
Paul Mason from Thermocalc Software.
Greg Olson from Northwestern Questec.
Carrie Campbell, NIST.
Brian Allison, University of Michigan.
Yamini from Ford. Pollock, UCSB.
General Motors, but now it's Ohio State University.
Michael Moore with ESI. Studia Kalidindi. Warren Poole. Michigan University.
Okay, thank you all. So please feel free to mingle with them and talk to them about more details about the report. I also wanted to give you a sense of the different affiliations of the people that were involved. Okay, so the composition of each team, I'm going to give you some background now on how the project was done. There's a team leader for each of the 5 teams and 9 to 10 top technical experts, not just in materials, but people that had experience in ICME We had at least one designer on each team, people more involved in applications, maybe not so familiar with ICME, a variety of materials types, experience in these areas. Although the majority of the members were from industry, there were key academics and government personnel as well. The mechanics, we had initial online meetings with just the team leaders, then 3 online team meetings. When I say online, rather than just conference calls, we had PowerPoints and worked interactively. Homework assignments that led into the 2-day in-person facilitated meetings. So we had, for each of the 4 technical teams, we had 2-day in-person facilitated meetings, then iterative editing of the report back and forth, and finally the 5th team, the review team, really did a lot of work in reviewing the final report and editing. I'd like to acknowledge the team leaders. Teresa Pollack from University of California at Santa Barbara was the Aerospace team leader. She is also the chair of the 2008 Academy Study. John Allison chaired the Automotive team. He was co-chair of that Academy Study. John DeLose chaired the Maritime team. He is really one of the materials go-to people in the Navy, who I've worked with in the past. Brad Cowles, who spent 37 years at Pratt & Whitney and is now a consultant, chaired our cross-cutting or pervasive issues team. And finally, our own Justin Scott, TMS Technical Projects leader, chaired the review team. And I guess you forgot to stand up during the acknowledgement, so you've now been acknowledged. Okay. I'm not going to go through this, but you got a sense of this from introducing the people. I just put this up there to give you a feel for the different affiliations. There was a mixture of people from big industry, smaller companies, academia, and government, and I think that integration is what we've been talking about is really a key, really important to make this type of thing work. Okay, so what were some of the outputs of the study? I'm just going to try to give you a flavor in this limited time. Just consult the study itself for the details of the people. There's a very strong and well thought out executive summary. It's about 8 pages, and we were very keen on doing this because we recognize a lot of people will not have time to dig into the details. I strongly recommend everyone who's interested read that executive summary. And there are nice hyperlinks from the executive summary to specifics in the chapters on the PDF version. Frameworks, and I'll show an example of one of these, of detailed steps needed to execute what we're calling this ICME Accelerated Product Development Program for each of the industrial sectors. Detailed actions at each of those steps in the frameworks and flow paths of information between those steps. The personnel, types of personnel in a company or supporting people in academia or the government needed at each step. Detailed strategies for addressing various barriers to ICME implementation. And in the near term, we repeatedly banged on the team members that the thing here was if you cannot give a solution to a barrier within the next 3 years, then you have to give some way to circumvent it. But if you can't give a solution or some way to circumvent it, we don't even want to hear about it. We don't want just problems raised. The idea was to see what we could do positively. Recommendations for more than 50 specific application opportunities. This was very interesting. This was one part of the facilitated meetings. When we asked for possibilities in the next 3 years, we thought we'd get a couple from each team. They just couldn't stop giving ideas. They really felt that there are many application areas that are approachable within these next 3 years, and they're all documented in the report. And I'll give some examples here. And then pervasive cross-cutting issues and recommendations. Some of them Jim alluded to, V&V verification, validation, uncertainty quantification, and so on. And they give some detailed recommendations of how to deal with those. And finally, the report contains not only references from the report, but then an additional reading list of all the ICME articles and so on that our experts were aware of. Okay, here's just a quick example of one level of one of the frameworks. This is for the aerospace industry, so you get a feel for it. Various steps starting with the customer and ending with the final serial production and even lifetime of the product. It's not really linear. It was difficult. We struggled with how to represent it. But you can see that there are feedback loops that go back and forth. The ICME implementation part The particular ICME tool set is especially in this dash box, so we have this exploded into another framework which is larger for each of the sectors. The key to these frameworks then are also related tables that go with each of the frameworks, and this is an example of the personnel for a given framework. Involved people like personnel like aerodynamics, fluid dynamics, concept designers, cost estimators, and so on. And then for each step in that framework, not only what the actions are that need to be taken, but who are the personnel from this list that would be involved in that step. Okay, some of the near-term opportunities, I just wanted to highlight a few just to give you a flavor for the types of examples that they came up with. In the automotive industry, for instance, high-pressure die-cast magnesium with holes and machine features for durability and crash resistance, and also high-performance crankshafts in the steel realm. In the aerospace industry, new alloys and nickel-cobalt design, space for turbine applications, and also the need to perform assessments in the next few years to reduce qualification costs on some existing materials. And in the maritime industry, duplex stainless steel is designed to reduce the number of repair cycles and also lower residual stress of high-strength low-alloy 65. So these are the areas they felt that an ICME accelerated program could be initiated in the next 3 years and really make a difference. One thing I should have added, I wanted to give you some feel for the process and the frameworks. I showed an example of a framework. I remember sitting at the Aerospace meeting in Teresa Pollock's shop in Santa Barbara, and the example is we tried to pull through that framework, the initial vision of the framework, different examples. We started, for instance, with an airframe example of an airframe component and pulled it through the framework, edited it, then we took an engine example, pulled it through the framework, and did the same with a composite material and a metallic material. And by the end of the process, same with automotive, we did something similar at John Allison's University. And by the end of the process, the people agreed that they felt comfortable that these frameworks were valid for the industry in general for implementing ICME. So strategies, another thing the teams tackled were developing strategies for addressing needs and barriers. And I'm just going to show you an example of one of the issues covered by the Maritime team. Some of the other teams also dealt with this. Felt it was very important to establish a business case. We don't have enough success stories, and we need more quickly in the near future to convince a chief engineer type to invest $100 million or however many million, or actually not that much, but maybe $10 million in this type of program to save $100 million. So here are some of the things they came up with. To encourage stakeholder buy-in, support a fully integrated ICME program, it's crucial to develop these qualitative and semi-quantitative business case analyses as soon as we can. As a first step, it could involve a joint effort among the end customers, this is from the Maritime group, of ICME, for instance, the shipyards, the acquisition warrant holders, and the maintenance officers and others, to identify what are the most promising application areas. Identify components that could benefit from incorporating ICME methods. Members of the community might begin by querying maintenance databases. The Navy has many databases with large amounts of data on this, and that could be a step towards showing where it would be valuable. As an alternative, they can also conduct a qualitative analysis to demonstrate that potential and work with Navy Mantech and shipyard programs, shipbuilding programs. We discussed the different types of people that could benefit from the report and why. I won't read these all. And it also discusses the different reasons why they could benefit. And I would contend that perhaps everyone in this audience could benefit from reading at least parts of the report. So I want to just summarize the study then. We developed these frameworks, gave detailed guidance and recommendations for addressing critical needs, more than 50 specific application opportunities, and also pervasive cross-cutting issues relevant to these all three and other industries as well. We can benefit a variety of different stakeholders in industry, academia, and government from this report, can benefit from this report. Now is the time for these people to act upon these frameworks and start using them to implement ICME much more broadly and rapidly. In that regard, the ICME teams were working so well together, they decided that they're going to stay together, and TMS is going to work with them on into the future beyond this report to act upon the recommendations in the report. So some final remarks I have is, I believe it's really, from my perspective, it's an incredibly exciting time in material science and engineering. And I think a large part of that for me is that we can now see these innovations in our modeling and our experimental approaches really accelerating materials discovery and manufacturing. It's now recognized as a very solid discipline worldwide. Awareness is growing rapidly, and it has great potential to do what the MGI talks about, reducing the time frame and the cost of developing new materials in manufacturing processes. But we stand at a critical juncture, and I think I'm stealing this word from John Allison, or a tipping point, I think, in this field. What is this critical juncture? Here I selected this drawing especially because there's no turning back now. You can see the no U-turn. There are still some questions that remain, but I think we're at a juncture where, to realize the vision, the detailed pathways to rapid implementation for practical problems, and now's the time to really elucidate them and execute those pathways. And this is sort of the goal of this study. So back to the 3 I's I'll end with. I hope that they sort of permeate the thinking from this talk and maybe set some tone for the rest of the Congress. Implementation, it's now time to get these things implemented across these industrial bases. In the near term, the team members felt the next 3 years to begin an ICME accelerated product development, many product development programs, was quite reasonable. And integration, it's absolutely critical to integrate not only experiments and models, but personnel. All the personnel in this room, I think it would be wonderful if everybody tried to talk, experimentalists team up with modelers and try to talk to people. If you're an academic from industry, we really need that kind of integration, and this is a good forum for that to happen. Thank you. Thanks for your attention.